Hello and welcome. I'm Caro from CaroMaths, and in this video I'm going to talk to you about Pascal's triangle. In particular, I'm going to take you through a couple of preliminaries, just a couple of things that I think you should be aware of before we start. Then we're going to build Pascal's triangle itself, and finally we're going to use Pascal's triangle to expand a plus b to the power n and a minus b to the power n, together with an example for each. So let's start. So like I said, there are a couple of things that you should have in the back of your mind at all times when we build Pascal's triangle, just because it makes everything a lot easier. The first one is y to the 0. And do you know what y to the 0 is? Well, any non-zero number raised to the power 0 is always 1. So y to the power of 0 is 1. And the second one is y squared. Well, y squared is exactly the same as 1 times y squared. And that might seem obvious right now, but it'll come in handy in a minute when we're going to build the triangle. So you've got those two things. Y to the power of 0 is 1, and y squared equals 1 times y squared. So before we build Pascal's triangle, why do we actually need it? Well, it comes in really handy when we expand a plus b to the power n, because it gives us the coefficients we need. So now let's have a look. The first expression is y to the 0. And what did we say earlier? Any non-zero number raised to the power of 0 is equal to 1. So here we've got y to the 0 is equal to 1. The next one is y to the 1, and that gives us 1 and 1. And that's because with Pascal's triangle, the first and the last numbers are always 1. So here we've got 1 and 1. There's only two numbers, so that's why it's the first and the last. Moving on to y squared. So we know the first and the last numbers are going to be 1, but this time we've got a number in the middle as well. And the number in the middle is, you can always get that by adding up the two numbers from the line above. So we add up 1 and 1, so the missing number is 2. And y cubed, so again, we've got 1 and 1 at the start and the end. And another thing to be aware of with Pascal's triangle is the second number, and the second from last number is always the number that you're raising the power to. So here we're raising to the power of 3. So the second number will be 3, and the second from last number will be 3. And you can also see that you get 3 by adding up 1 and 2 and 2 and 1. And finally, I want to talk to you about y to the 4, but I just want to give you a moment to see if you can figure it out yourself. So have a go. So did you manage to do it? Well, again, the first and the last number is always 1, and the second from last number will be 4, because we're raising y to the power of 4. And then there's one number missing in the middle, and we just get that by adding up the numbers from the line above, 3 plus 3, so it's 6. And we can just carry on like that forever. And I'd encourage you to do that. Just maybe try y to the 5, y to the 6, just to really get the hang of it. And now let's move on to expanding a plus b to the power of n. I'm just going to put Pascal's triangle here, or a shorter version of what we've just worked on, just so we can refer to it when we work out the expressions. We start with our first expression, a plus b to the power of 0. And we said earlier that any non-zero number to the power of 0 is just equal to 1. So a plus b to the power of 0 is equal to 1. A plus b to the power of 1, well, that's 1 times a to the power of 1 times b to the power of 0, plus 1 times a to the power of 0 times b to the power of 1. So let me explain that. The two 1s, the coefficients, you get from looking at the second row of Pascal's triangle, 1 and 1. And now I'm going to explain the powers when you expand this expression. So what you do is you start with the first term in the bracket, which is a, and you raise it to the highest power, which in this case is 1, because we expand a plus b to the power of 1. And you start the second term in the bracket, which is b, and you always start that to the power of 0. And then what you do is you count down the powers of a and you count up the powers of b. So that's why the second expression, we count down the powers of a from 1 to 0, and we count up the powers of b from 0 to 1. But of course we can simplify this expression slightly, and it can be simplified to just a plus b, because 1 times an expression is just the expression, and any non-zero number to the power of 0 is just 1. So that leaves us with a plus b. A plus b squared is starting to be a little trickier, and it is a squared times b to the power of 0 plus 2ab plus a to the power of 0 times b squared. So firstly, we can see from the third row of Pascal's triangle that the coefficients are 1, 2, and 1. But as we said earlier, any number times by 1 is just the number itself, so we don't bother putting the coefficient of 1 in there anymore. But let's have a look at the powers. In the first term, a squared times b to the power of 0, a is raised to the power of 2 because the whole expression we're expanding is raised to the power of 2, and b in the first term is always raised to the power of 0. Then the second term is 2ab, so we get to that by taking a squared from the first term, and we'll count down by 1 power to get to a to the 1, and we count up b to the power of 0 by 1 to get to b to the power of 1. And similarly, in the third term, we get to a to the power of 0 by counting down from a to the power of 1 in the second term, and we get to b squared by counting up 1 power from b to the power of 1. But again, we can simplify this slightly to get a squared plus 2ab plus b squared. And I've actually done another video where I show you a slightly different and more visual explanation and derivation of this expansion of a plus b all squared. So check it out if you're interested. And the last one I want to show you is a plus b cubed. And if you look at the fourth row of Pascal's triangle, you can see that the coefficients we're expecting are 1, 3, 3, 1. And I just want to give you a moment to see if you can work it out yourself, and then I'll explain to you how it's done. Okay, so I hope you managed to have a go. And the expression is a cubed times b to the power of 0 plus 3a squared b plus 3ab squared plus a to the power of 0 times b cubed. And as you can see, the coefficients are 1, which we don't put, 3, 3, 1. And the powers, so we've got a to the power of 3 because that's the power of the expression we're expanding, and b to the 0. And as you go through each term, you count down the powers of a and you count up the powers of b until you end up with a to the power of 0 and b to the highest power. And there's one little trick I want to share with you as well, which you can use to check your workings, and that is to make sure that when you add up the powers of a and b, they always add up to the power of the expression that you're expanding. So here the power is 3, so let's have a look at each term. A cubed times b to the 0, you've got 3 plus 0, so the sum of the powers is 3. And we've got a squared and b, so a squared, the power is 2, and b, when there's no power, it's just the power of 1, so 2 plus 1 is 3. And similarly, a and b squared, so we've got 1 plus 2 is 3. And in the last one, it's a to the power of 0 times b cubed, so again the power is 3. So we've done it right. And now we can simplify this to get a cubed plus 3a squared b plus 3ab squared plus b to the power of 3. And you can get going and going And again, I encourage you to try a few more just to get some practice in. But basically, I've shown you how to build the triangle, so you just need to build it far enough to expand the term that you want. But that's the way that you can expand any term up to the power of n, as long as you make your Pascal's triangle large enough. And now let's have a look at expanding a minus b to the power of n. The principle is exactly the same as expanding a plus b to the power of n, but you need to be very careful here, because as you can see, b is a negative number. And you should know that if you take a negative number and you raise it to an odd power, the result is negative. And if you take a negative number and you raise it to an even power, the result is positive. So let's see how that pans out. Firstly, I'm going to put Pascal's triangle here again, just to remind ourselves of the coefficients. So again, we start with to the power of 0, so you've got a minus b to the power of 0, but that's still equal to 1. That doesn't change because any non-zero number to the power of 0 is equal to 1. Then a minus b to the power of 1, well, that's 1 times a to the power of 1 times b to the power of 0, minus 1 times a to the power of 0 times b to the power of 1. And I'm not going to go through everything again in detail like I did on the last slide, because, as I said, the principle is the same, but I just want to concentrate on the terms and whether it's positive or negative. So here, the second term is negative, so minus 1 times a to the power of 0 times b to the power of 1. And that's because b is raised to an odd power, which is 1. And then we can simplify this expression slightly to get just a minus b. And a minus b all squared, well, that's equal to a squared times b to the power of 0 minus 2ab plus a to the power of 0 times b squared. So the second term, minus 2ab, it's negative because b is raised to the power of 1. So if we don't put the power, it's just assumed it's the power of 1. So that's why it's negative. But then the third term is positive because we're raising b to the power of 2, and that's an even power. So even though b is a negative number, the result is positive. And we can just simplify this to get a squared minus 2ab plus b squared. And I've done a video here as well for that expression on how to expand it in a slightly different way. So again, check it out if you're interested. And finally, we've got a minus b cubed, and that's equal to a cubed times b to the power of 0 minus 3a squared b plus 3ab squared minus a to the power of 0 times b cubed. So the second term minus 3a squared b, b is to the power of 1, so it's a negative term as a result. 3ab squared, b squared, the power is even, so the resulting term is positive. And minus a to the power of 0, b cubed, is a negative term because it's to the power of 3, which is an odd number. And that can be simplified to a cubed minus 3a squared b plus 3ab squared minus b cubed. And again, make sure you just double check the powers that they all add up to 3 just to make sure it's correct. And again, you can keep going and do get a bit of practice, and it makes it a lot easier. And if you get stuck, just post a comment below and I'll do my best to help you. So now let's have a look at a couple of examples. I find examples really useful because they help me get my head around an issue by just practicing. So here's Pascal's triangle, and I've colored the fourth row orange because that's the one we'll be looking at. And the example I've got here is y plus 2 cubed. So the first term, the coefficient will be 1. We can see that from a Pascal's triangle. And then we've got y to the highest power, which is 3, plus 2 to the power of 0. So it's 1 times y cubed times 2 to the power of 0. With the second term, we know the coefficient will be 3, and we count down 1 power from y cubed to get to y squared, and we count up 1 power from 2 to the power of 0 to 2 to the power of 1, or just 2. So it is plus 3 times y squared times 2. For the third term, the coefficient again is 3, and we count down from y squared to get to y, and we count up from 2 to the power of 1 to 2 squared. So it is 3 times y times 2 squared. And finally, for the last term, the coefficient is 1, and we count down from y to the 1 to y to the 0, and we count up from 2 squared to 2 cubed. So it is plus 1 times y to the power of 0 times 2 cubed. And that is a very long and messy expression, and we really want to simplify this. So let's have a go. The first term simplifies to just y cubed, then plus 6y squared, because you've got 3 times 2 times y squared. The third term, we've got 3y times 2 squared, so 2 squared is 4, times 3 is 12, so we've got plus 12y. And the final term is 2 to the power of 3 times 1 and times y to the power of 0, which is just 1. So 2 to the power of 3 is 8, so it's plus 8. That's the first example. And now I want to share an example with you where we've got a subtraction in the bracket rather than an addition. Firstly, I'll pop our Pascal's triangle here, and again we're going to be looking at the fourth row, and the example I've got is y minus 4 to the power of 3. Right, so let's have a go. The first coefficient will be 1, and then we've got y to the highest power is 3, and times minus 4 to the power of 0. So we get 1 times y cubed times minus 4 to the power of 0. The second term, the coefficient will be 3, and we count down from y cubed to y squared, and we count up from minus 4 to the power of 0 to minus 4 to the power of 1, which is just minus 4. So we've got plus 3y squared times minus 4. For the third term, again the coefficient will be 3, and we count down from y squared to get to y, and we count up from minus 4, so minus 4 to the power of 1, to minus 4 to the power of 2, or minus 4 squared. So the term is plus 3y times minus 4 squared. And finally, the last coefficient will be 1, and we count down from y to the power of 1 to y to the power of 0, and we count up from minus 4 squared to minus 4 cubed. So the expression will be plus 1 times y to the power of 0 times minus 4 to the power of 3. And now let's simplify this and really pay attention to the minus 4 and how it affects whether the whole term is positive or negative. So the first term, we get 1 times y cubed times minus 4 to the power of 0, but minus 4 to the power of 0 is just 1. So we're left with just y cubed. The second term, we've got 3 and minus 4. Well, 3 times minus 4 is minus 12, so it's minus 12y squared. The third term, minus 4 squared, so we've got minus 4, which is a negative number, but it is raised to an even power, so minus 4 squared will be plus 16, and 16 times 3 is 48, so that gives us plus 48y. And finally, you've got minus 4 to the power of 3, so it is raised to an odd number, and that means that the resulting term will be negative. So minus 4 to the power of 3 will be minus 64. Y to the power of 0 is just 1, so the resulting term will be minus 64. So the final expression is y cubed minus 12y squared plus 48y minus 64. And that's it for this video. I hope you find it useful. If you do, then please like and tell your friends. Also make sure that you hit that subscribe button and click on the notification bell so you're always notified when I upload a new video each week. And if you've got any burning issue, something you'd really like to learn about, then let me know and I'll make a video about it. Also, if you've got any questions about what I've done in this video, let me know in the comments below and I'll be able to help you out. And as always, thanks for watching and see you soon. Bye bye.